In the silent, freezing expanse of the interstellar medium, a traveler emerged from the darkness, crossing the invisible boundary into our solar system. This was 3I Atlas, only the third confirmed interstellar visitor in recorded history. Unlike the rocky Oumuamua or the clearly cometary Borisov, Atlas arrived with a profile that defied easy categorization. It was moving at a velocity that suggested an origin far beyond the gravitational reach of any local star, carrying with it the chemical signatures of a distant, alien sun. But as it drew closer to our sun, the initial excitement of the scientific community was quickly overshadowed by a growing sense of unease. The data streaming back from our most advanced observatories began to show inconsistencies that couldn't be explained by standard orbital mechanics. It wasn't just the object itself that was mysterious, it was the way the information about it was being handled. For the first time in the era of modern astronomy, a celestial event of this magnitude was being met not with total transparency, but with a series of redacted reports and delayed releases that left many wondering what exactly we were looking at. The detection of 3I/ATLS was a triumph of the Asteroid Terrestrial Impact Last Alert System, or ATLAS. Designed to protect Earth from rogue impacts, it instead caught a ghost from another world. The initial discovery data suggested a typical hyperbolic path, but as independent researchers tried to refine the orbit using public datasets, they encountered a wall. Large segments of the high-resolution imaging data, usually shared within hours, were being held back for internal review. This delay created a vacuum of information, soon filled by speculation and rigorous peer review of the scraps that did leak out. The controversy began when the Minor Planet Center noticed subtle non-gravitational accelerations, pushes that weren't caused by the sun's gravity. While outgassing is the standard explanation for comets, the spectroscopic analysis of 3I/ATLAS showed an absence of the typical carbon-based gases associated with such movement. This discrepancy was the spark that ignited the flame of scientific dissent, turning a routine astronomical observation into a geopolitical debate over who owns the data of the cosmos. The data gap of 3I/ATLS refers to a specific 48-hour window during its closest approach to Earth, when the most sensitive instruments, including the James Webb Space Telescope and several classified orbital assets, were pointed directly at it. During this critical period, the public archives showed a maintenance downtime that many astronomers find statistically impossible. When the data finally emerged weeks later, it appeared heavily processed, with low signal-to-noise ratios that obscured the fine details of the comet's surface. Independent analysts, using raw telemetry from amateur ground-based arrays, claimed to see a structure that was far more geometric than a natural ice ball should be. This led to the formation of an international coalition of scientists demanding data transparency. They argued that because an interstellar object is a matter of global heritage, the raw, unprocessed sensor data must be released to the global scientific community. The tension between the need for national security and the quest for scientific truth has never been more apparent than in the struggle to see the true face of 3I/ATLS. What were they hiding? To understand the controversy, we must look at the anomalies. 3I Atlas exhibited a light curve that was highly unusual, suggesting a very elongated shape or an unsurface with varying levels of reflectivity, albedo, that changed in a rhythmic, almost artificial pattern. Standard comets brighten and dim as they rotate and release dust, but Atlas showed a precision in its pulse that defied the chaotic nature of outgassing. Furthermore, thermal imaging revealed that the object was significantly cooler than expected, as if it were reflecting heat rather than absorbing it. Some theoretical physicists, including those associated with the Galileo project, suggested that we might be looking at a thin film object, perhaps a piece of interstellar debris that wasn't a rock at all. The lack of a visible dust tail, despite the measurable acceleration, pointed toward a mechanism of movement that didn't involve the expulsion of mass. If it wasn't a comet, and it wasn't an asteroid, the implications are staggering, and the silence from official channels only fueled the fire of these radical theories. The involvement of government agencies added another layer of complexity. Reports surfaced that the Department of Defense had tracked 3I-Atlas using sensors designed for monitoring ballistic missiles and orbital debris. This data, which would be the most precise in existence, is classified by default. The controversy isn't just about what NASA is sharing, but about what the military-industrial complex knows and refuses to say. In the past, similar data from Oumuamua was eventually used to confirm its interstellar origin, but with 3I-Atlas, the shutter remained closed. The official stance is that the sensor capabilities are too sensitive to reveal, as doing so would give adversaries a roadmap of our surveillance net. However, the scientific community argues that the signatures of an interstellar object are distinct from man-made craft and could be released without compromising national security. This stalemate has created a two-tiered system of science, one where the elite have access to the truth of the universe, and another where the public is left with filtered, second-hand interpretations.
For the independent astronomer, the 3I/Atlas event was a masterclass in frustration. Many spent months preparing for the transit, only to find their access to coordinated observation windows denied or pushed back. This wasn't just a matter of ego, it was a matter of lost opportunity. Interstellar objects move so fast that we only have a narrow window to study them before they disappear back into the void. By the time the controversy over data transparency reached the mainstream media, 3I-Atlas was already moving toward the outer solar system, its secrets fading with its light. The grassroots movement that emerged, Science Without Borders, began crowdfunding their own small sat missions to intercept the next visitor, realizing that relying on government-funded agencies might no longer be enough for those seeking unvarnished truth. The Atlas incident has become a rallying cry for a more decentralized, transparent approach to space exploration, where the data belongs to the species, not the state.
The most controversial theory remains the most compelling, that 3I/ATS was a technosignature. If the data regarding its acceleration and lack of outgassing is accurate, it matches the profile of a light sail, a piece of technology that uses the pressure of starlight to navigate. While many in the scientific establishment dismiss this as wild speculation, the refusal to release the high-resolution imagery only makes the theory more resilient. If the images showed a jagged, natural rock, the debate would end. But if they showed something else, smooth surfaces, right angles, or structural bracing, it would change everything we know about our place in the cosmos. The controversy over transparency is, at its heart, a controversy over the possibility of the other. By withholding data, agencies aren't just protecting sensors, they are potentially gatekeeping the most significant discovery in human history. Whether 3I/ATS was a strange rock or a silent probe, the way we handled its arrival suggests we are not yet ready for the answers we claim to be seeking.
As 3I-Atlas exits our neighborhood, it leaves behind a legacy of questions and a demand for change. The controversy has forced a global conversation about the ethics of space data. Future missions, like the European Space Agency's Comet Interceptor, are now being designed with open data charters to prevent a repeat of this opacity. We are learning that in the search for interstellar truth, the tools we use are just as important as the transparency of the results. The story of 3I-Atlas isn't just about a comet, it's about the evolution of science in an age of secrecy. It challenges us to build a world where the stars are not the property of the few, but a frontier for all. As we wait for 4I to appear on the horizon, the scientific community remains vigilant, ready to demand that the next time a visitor from the stars knocks on our door, we all get to see who or what is standing on the other side. The mystery of 3I-Atlas may never be fully solved, but the fight for the data it left behind has only just begun.